doggone semester is so short. There's no way on earth I can get through all this if I don't give you 2 tests today. I mean, no way on earth. And we don't do this in the spring and in the fall, but we have to do it in the summer, particularly when you're taking these courses. Now let's jump into this. Technician A says module communication networks are used to reduce the number of wires in a vehicle. This is test 2. Engine performance 2, test 2. They are used to do that. I talked about that yesterday. Technician B says communications network is used to share data from sensors, which can be used by many different modules. That's both of them right. A module is also known as a what? A node. A node. A high-speed CAN bus communicates with a scan tool through which terminals? 6 and 14. Remember that. High-speed CAN bus communicates with a scan tool. There's a low-speed CAN bus and a high-speed CAN bus. Then there's the other buses that don't communicate very fast at all. Incidentally, I've got an article that I wrote for Mobile Air Conditioning Society about networks that you might want to read. It's pretty good. Cars that got networks. UART is an old network. UART uses a signal that toggles between 0 and 5 volts. That's going to be A. Class 2 communication toggles between, that's GM Class 2, between what? That's 0 and 7 volts. Now remember these. There's going to be a pop test on this. Which terminal of the data link connector does General Motors use for Class 2 communications? Terminal number 2. So when I say data link connector, everybody knows what I'm talking about. You got a picture of a data link connector in your mind? That's this connector under the dash. It looks like this. Right? Okay. Remember I told you pin 16 is always hot. Pins 4 and 5 are ground. Those are the 2 constants. 16 is hot, 4 and 5 are ground. You plug your scan tool in, it won't talk. I want to know if I got power here. Usually if you ain't got power there, your cigarette lighter, your PowerPoint fuse is blown. It'll be the same one. Got that? Yep. Remember that. Remember. 16 is hot. 4 and 5 are ground. 4, 5. And the way these are numbered is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, no, something like that. I may have that all screwed up. We better not go my minor numbers on that because I think I messed that all up. Anyway, memorize that. We're all going to give ourselves a pop test on that. But this is what 16 is down here, 4 and 5 are up there. I do know that. They may have the numbers like that, but I do know that one's 16 and those are 4 and 5. Okay, which terminal, let's see, does a data link connector use for Class 2? That's pin 2. GM LAN is a General Motors term for which type of module communications? That's high-speed CAN. Got it? Local area network, right? I guess, or control area network, what CAN stands for. CAN H and CAN L operate how? Got that? CAN H is at 2.5 volts when not transmitting. CAN H goes to 3.5 volts when transmitting. CAN L is at 2.5 volts when not transmitting. All of the above. That's a D. Now, you guys don't neglect to read these chapters because you're going to get a lot of stuff I don't have time to tell you right here. But that reading them, if you don't read the chapters, then don't expect to pass the ASC test. You got it? All right. Now, which terminal of the OBD2 data link connector is a signal ground for all vehicles? 5. See that? Terminal 16 is 12 volts. Got it? I already said that. Technician A says a breakout box, Bob, can be used to access the bus terminals while the scan tool is used to activate the modules. Technician B says a 38-cavity diagnostic connector found on many BMW and Mercedes vehicles under the hood. Both of those guys are right. They actually have a scan, and I've got one out here, a little breakout box that plugs into the data link connector so you can actually just check your data link connector terminal real easy. It's got a data link connector. Plug it in. It's a little box that's got 16 holes on it, and you can actually check each one of those with a meter right there. Real simple by just plugging that thing in. Michael probably got one in there. Yeah. All right. The process of sending multiple signals of information at the same time over a signal wire and then separating them is called multiplexing. You see, everybody, it's like a freeway. You know what serial interface is versus parallel interface? Let me do this right quick. Okay. Your PCM, a lot of what it does is parallel interface because it's got all these wires coming out, right? But at least one pair of these wires is twisted around each other and it's coming out. And that is a serial interface line and it goes to other modules. But the signal's coming in to the PCM and you got power and ground, all this other kind of stuff. But a lot of these signals are coming on their own little wires, see? But it'll take that information and send it out to the modules. Multiplexing means it's like you got cars driving on a freeway that are merging. You know, some of them are leaving whenever they need to go to, like a whole bunch of cars going this way. This one here wants to exit it and lose you, but the next one's going to hop. See what I'm saying? That's how it works. It's just happens a lot faster. Low-speed networks operate on less than how many bits per second? 10,000 bits per second. 10,000 bits per second. The UART data bus operates at a baud rate of 8192. That's basically a frequency thing. Which of these, commonly designated D2B, is an optical bus system connecting audio, video, computer, and telephone components in a single ring structure with a speed of up to 5,600,000 bits per second? When I say optical, what I mean? That's domestic digital bus is what that is. Basically, optical means that it's with light. Do you know there was a man a long time ago that says one day all of our telephone messages are going to be traveling on beams of light? And everybody that he was talking to went, whoa. They said, how do you figure? And he got a glass rod and he demonstrated it. And you know who that guy was? The guy that invented the telephone, Alexander Graham Bell. He saw that way back. That's how sharp that guy was. He was 80 years old, I think, at the time, too. Don't sell them people short. All right. Which terminal of the OBD2 data link connector is chassis ground for all vehicles? 4. All right, so remember, totally 4 and 5 are ground. An OBD2 140 is able to provide engine serial data. If there are terminals in which cavities of the DLC? 1 and 3. Now, the DLC on an OBD1 Ford has got a different shape. You got to know what that's look like. It's looked like, you've seen that. The Escort and the Bronco have them. It's a housetop shaped connector. It's got 6 terminals in it, right? Except I'm drawing it wrong. 1, 2, 3, 4, like that. And then there's another terminal by itself. When you short this one to ground, and you're going to get a sheet on this one of these days, not going to take you long to go through it. You short that one to ground, your check engine light will flash out in the trouble code. And also it's flashed out at a terminal over here. That's how we used to do that before Ford. Ford didn't even have a check engine light before 1988. You know, I learned to measure voltages on all the sensors and learned what they were supposed to look like. Smartest thing you can do if you want to get good at doing engine repair, engine conformance work, you know, and emission and all, is plug into as many good vehicles as you can. Look at the good ones. Get to where get where you know what the good ones are supposed to look like, and then when you plug into a bad one, it'll stand like a sore thumb. Bam! I know that ain't right because I've seen too many that aren't. Okay. Which of these is a version of a byte, flight, and a high-speed serial communication system for in-vehicle networks? FlexRay bus. We're flying about all kind of buses today, ain't we? Somebody done thrown us under the bus. A single-wire serial communications protocol that uses one master control module and many slave modules is called a Motorola interconnect. All right. Technician A says a CANDI module will flash the red LED rapidly if communication is detected. And Technician B says a twisted pair is where 2 wires are twisted to prevent electromagnetic radiation from affecting the signals passing through the wires. B is the guy that's right on that. The CANDI module's not going to flash
Something
that.
like your microphone sensor or something like that?
Huh?
Come on, like a shielded wire, right?
Yeah. As a matter of fact, on that ignition board up there, you can see that the crank sensor wire is twisted around itself. You know, they're twisted around each other, and they got foil wrapped around them. That foil is grounded. And it's going to let me show you what it looks like on a schematic. If you've got 2 wires on a schematic, you're going to see a dotted, looks like a drum almost. It's dotted around them like this. And it's going to be grounded. But see, that's a shielded wire. That dotted line around that thing, it's just letting you know that it's shielded. I mean, it'll be going from, but it'll also, a lot of them will draw out where these wires right here are snaked around each other like that. And that's how they look. Now, I will tell you that on your CAN bus, they have to have 1 twist every 3/4 of an inch. They got to be tighter than others. And on some of the Dodge vehicles years ago, there was communication problems with one of their buses, and you had to there was a little line going through the engine compartment that was twisted like this, and you had to take it loose from one end and put more twists in it. That was the fix. It would take care of that. Got it? Technician A says the Chrysler OBD1 vehicles were equipped with a bus system called Serial Communications Interface, SCI. Technician B says Chrysler Programmable Controller Interface, PCI, is a 3-wire communication protocol that connects to OBD2 to Terminal 2. Wrong. A PCI is a 1-wire bus. Okay, you got to remember that. Technician A is the only one that's right there. You know, and everybody's got different names for their networks. All right. And I tried to get through this quick so that we would not even have issues. We don't want to have issues, do we?
We got.
Huh?
No, that's the mission.
Huh?
There's one on the back of this one. What is the mission step?
The emissions.
Yeah, well, it shouldn't be. The emission test we could take tomorrow. Yeah, since I didn't mean that print on the back. If we print it on the back, just hang on to it. So we'll do our emission test. We can do that tomorrow, and we'll do that and all that. And I hope you guys enjoyed the class today.